We're going to go ahead and get started. We have everything loaded. I'm Judy Noodleman, Westminster resident, and I'm excited to introduce Betsy Greytok, IBM Vice President and Associate General Counsel for Responsible Technology. I'm excited as a Westminster resident. I'm excited as an IBM retiree who participated in rolling out new technology areas from the 60s into the early 90s. I think those technologies laid the foundation for tonight's topic of AI and quantum computing. Betsy attended UT Austin for all her degrees as an undergrad with a bachelor's in business administration, earning a master's in business administration, and earning her JD, Doctor of Law. After completing her law degree in 1993, she joined Aiken, Gump, Strauss, Hauer, and Feld in commercial litigation practice, which included intellectual property infringement claims. Betsy joined IBM in 1999 as senior counsel and has held executive positions which have continued to span new technology. Today, Betsy helps IBM navigate the dynamic world of governing data and AI, and helps IBM to explore the issues that may arise with emerging technologies such as quantum computing. Their goal is not just to deliver innovation that matters, but to do so with trust and responsibility built into delivery. This evening, Betsy's talk will focus on machines that think, computers that quantum leap, and many of us eagerly await what we can learn from her. Please join me in welcoming Betsy to Westminster.
That was quite an intro. Did you use AI, Judy, to write that? Did you use AI? I don't remember sending that. My name is Betsy Greytok. I am with IBM. I am required to give you a disclaimer that everything I share here tonight are opinions of myself and not necessarily those of IBM. Then what I'm showing up here is confidential, so you can feel free to share it with your friends and family to the extent that they're interested in AI. I will give you a disclaimer up front. I'm an attorney. I have zero technology skills. I am not an engineer by training. If you are a physicist, you're way far ahead of me. If you're a mathematician, you're way far ahead of me. I am in the class of, when you talk about AI, you talk about algorithms. I had to go look up what that means. Can barely explain it or spell it either way. So if you're in that boat with me where you're like, I vaguely remember there was an algorithm mentioned in a class back in high school, you're in my boat. If you're the mathematician, please be patient with me because I'm sure I'll make mistakes. But as an attorney, I have to take technology and make it simple so that our attorneys can negotiate contracts. If you should end up in litigation, the jury can understand the technology that you're selling. And then part of what I do now is how a company governs AI. So you can't just let AI run rampant within your company. You need to have governance policies around that. You have to comply with regulations, and you can't govern what you don't understand. So I do take the complicated technology, get it to where I understand it enough and can come up with all of those policies. So with that, I will try to explain it. I'm used to explaining it to a room full of attorneys who are like me and clueless as to technology. If it's below your level, like I said, just forgive me. So let's see, it is a little messed up because we had to alter the files to get it to fit, but let's go through what AI is. It's an algorithm, and like I said, when I first was starting to say I'm going to have to explain what an algorithm is, it's basically an instruction. So an algorithm says, if you see this, then take this action. So if you see a green light, proceed through the green light. If you see a red light, you need to stop the car. So that's a type of algorithm. And they get very, very complicated, but just keep in mind, it's basically an instruction. And then on top of the algorithms, they use what's called weights. And so as an AI model, artificial intelligence model learns, it's an algorithm, and they're going to tell it what's important, that gets a heavy weight, and what's less important, and it gets a lower weight. And so if you were to say how to tie your shoe, you might put heavier weight on the fact that you have to complete a loop, and lower weight on having to go through the loophole because you may assume that the shoes are already tied. So that's a lower instruction, and the more important instruction is that you get the loop tied. AI is trained on lots and lots of data. You've probably heard of scraping the web, and so yes, they scrape information off of the internet, they ingest books, anything that they can gather under law. IBM is very adamant about that, so applying copyright law, we do follow the law, but it's large amounts of data. When you ingest data like that, there's two ways to do it. So you can label the data and you can say, this is a textbook, it's about medical information. Not only is it medical information, it's about oncology. And we're going to talk about oncology that impacts the blood system. And so the labels get more and more detailed. As you can imagine, if you're going to build a model that is going to cover a lot of different topics, having people go through and label all the different types of data is very, very time-consuming, very, very expensive. And so when you're working with labeled data, that's super expensive data. And when you're working with unlabeled data, it is just a pile of words. That's literally what it looks like to the machine, to the computer, is it's a pile of words that you're going to get it to ingest. So you'll also want to learn about single-purpose models and multi-purpose models. I'm going to guess everybody in here has heard of ChatGPT. Is there anybody who has not heard? So ChatGPT is, we'll get into this in a little bit, but artificial intelligence at this point can basically, you feed it a question similar to a Google search, and it will come up with an answer. But a Google search is going out and looking for snippets of similar information on the internet, and it says this was similar. That's basically all that it does. It's a matching game. Artificial intelligence will look for patterns, and based on what you put in as the prompt, that's the pattern it's going to bring back to you. So a single purpose model, and IBM was working on these models back when Judy and Terry was also with IBM when they were working on these models back in the 50s. So they've been working on these a long time. But they started out with single purpose models. So you would take a large amount of data, you would label it, it would be about one topic, and it would do one thing. So a common one that people heard about in the mid-2000s was a radiologist being able to use artificial intelligence to help it read x-rays and judge whether a tumor is showing up on an x-ray. You had a model that did one thing, that's all it did. You now have multi-purpose models, which is something like ChatGPT, and it can do many different actions, and mainly what you engage in is that you're going to put a question in and it's going to give you an answer back. So you'll also hear about LLMs, or large language models. So that just tells you what type of model it is. It's going to converse with you in a language. There's other types of models around molecules, around I've got it listed on the other page, chemical components, so there can be different models that don't necessarily converse with you in a natural language, but most of what you're engaging with is a large language model. And then this is what is key, is the output is a prediction. It's not a search engine like Google is, but the way that they train these AI models is you take this pile of data, large pile of data, it's basically a bunch of words. The words are broken down into different components, usually by syllable. Each component is then assigned a number called a token, and the computer, the algorithms, can read those numbers. You now put it into a language that the computer can read, which is numbers, and it can start to learn the patterns. And so these learn the very complex patterns. Imagine if you broke English down into all all of the different patterns, including patterns that you get from different dialects from across the country, different dialects from other countries, different word usages. It studies all of those patterns. And when you put in a prompt, it takes that and turns that into a pattern and says, okay, I recognize these words. These words, you put in words, I got a pattern now. And based on that pattern, I'm going to predict what to say next. So if I put in a prompt into ChatGPT, and I did test it on this, I've spilt my milk, what should I do? And I put that in because I wanted to see, it's a prediction, so it's going to go with what it has seen the most in that big pile of data that I gave it. And I was thinking it might come back with don't cry. If I put in, I just spilled my milk, what should I do? It would say don't cry. It didn't do that. It came back and it said, well, you should go get some paper towels and you can mop up the milk. And so it just gave regular instructions, but it's predicting what I wanted based on the prompt that I gave it. So that's kind of AI at the very base level. If anybody's a Jeopardy fan, and you happen to be watching back in 2011, IBM had a machine called Watson that played Jeopardy and won. That is an example of a single purpose model. It was trained to do one thing, which was to play Jeopardy. It couldn't do anything else. It couldn't help medical doctors with diagnoses. It couldn't help space engineers figure out complex problems. It couldn't help you plan your next trip to France. It did one thing. It played Jeopardy. It famously got this question wrong. The category was U.S. cities, and the answer was its largest airport is named for a World War II hero. Its second largest for a World War II battle. Anybody know the answer? Know the question? What is Chicago? Watson wrote, what is Toronto? It literally put the question marks up after it wrote, what is Toronto? So you remember I talked about weights? It says the weights tell the models what's important and what's not important. When we trained Watson, we said the category, not very important. Because the categories kind of give you hints, but they can sometimes do puns off of the categories, and it's not necessarily indicative of how the answer is going to play out. So it wasn't paying a lot of attention to U.S. cities. It kind of gave it, maybe it's a U.S. city. In a lot of its training, North America and United States and U.S. were used interchangeably, so it went with North America instead of just U.S. And then Toronto had been entered into the training materials such as the National League of Baseball, and so it was a little bit confused as to whether Toronto actually fit into the category of U.S. cities. I don't know why it didn't come up with Chicago, but it didn't. That type of model actually had a confidence rating, and the confidence rating on its answer was 17. And when it's that low, the model is trained to not answer. But we had told Watson, you have to answer. So we turned off that capability to not answer. It had to answer. It didn't like doing it because the confidence level was so low, so it threw up a bunch of question marks to show that it wasn't. So that's an example of a very old model, and it's a single-purpose model. So now in the news, you may have heard of foundation models versus frontier models. A foundation model is simply one of these multi-purpose models. They're trained on huge amounts of unlabeled data, and they can do many different things. They can answer questions about science, they can answer questions about history, you can say, I'm feeling unwell, what do you think I have? Here's my symptoms that I'm experiencing. It will start engaging with you in a conversation. Do not take medical advice from any of these. You can take it to your doctor. They'll be a little upset with you for playing with AI, but you can go and say that. They'll do lots of different things. Then frontier models are the fact that these models have gotten so large that they're much more capable. So these really came out in 2022. ChatGPT really hit the scene. Since then, their capabilities have just grown exponentially. If any of my scientists in the room, you will remember Moore's Law. We've blown it out of the water. So frontier models are super powerful, and they're a lot more accurate than when you first saw them. and I'll help you walk through like how they come to be more accurate. But if you're hearing foundation model, they're talking about a model that can do a whole lot of different things. You typically engage with it as Gemini, ChatGPT. I like to use Claude. And you can think of it as a foundation that we're going to use for more specific AI systems. So foundation model, frontier model, super big, super powerful, can do many different things. Like I said, large language model, that's the nature of the output. You can have ones that are going to output images. You can have multimodal models, which will put out an image and a language. They can put out software code. They can put out proteins. Some can now talk to you, so they'll put out speech, molecules, which is science going over my head. And then you'll hear generative AI or Gen AI, as talking with your kids and your grandkids, they'll call it Gen AI. That's just indicating that it generates content. So you're going to ask it a question, or you're going to give it a prompt, is what they call it, and it's going to give you some content back. So why is the world fascinated with all of these models? And I'll show you while I'm using courses as my AI trainees here in a little bit. It's cost savings. So if you think back to the days of Watson, IBM spent a ton of money to prove to the world that AI models were so powerful, and we trained it just to play Jeopardy. So that was basically a marketing investment for IBM. We trained, spent a lot of money, spent the model to do one thing, that's all it could do. This doesn't scale in the marketplace. We then had Watson Health. Watson Health was trained to do different tasks within a medical setting. We had the Watson Oncology, we had Watson Radiology, but all of these models were taking a huge amount of data that is labeled, super expensive, and when you got done with it, it could only do one thing. So that type of product, for those of you in manufacturing and sales, not going to scale, not going to sell a whole lot of these, and your cost of good was so high that you can't get, it's not affordable for a lot of people. So then you bring in these great big multi-purpose models. So that's your foundation. It's already trained to do a lot of different things, and you can go through a process that they call fine-tuning and have it do specific things from there. So you start with your foundation model, and you can think of that as a generalist. And by a generalist, I would say this is a high school student. The model, your basic model, now they're acting like they've got PhDs in 400 different topics, but it's basically a high school student. It's trained in a lot of different studies, but it's not really got any core ingredient. And then as you take it to the specialized model within a medical setting, within a research setting, within an enterprise setting where it's going to do your accounting now, you do this fine tuning, which is equivalent to sending it to college, right? You send it to college, it got a degree in accounting. It's doing pretty good. You send it off to get the CPA, you decide you want it to know even more, it may go to graduate school, it may get a PhD. So all of that specialized training gets built off that one foundational model. That you can do, you spend a lot of money to get the model that can do many different things, but you can sell it to now thousands, tens of thousands, hundreds of thousands of people and enterprises who can then tailor these models for their specific purposes. So this is why you see it, everybody says we're at an inflection point. This is a big change like the industrial age. This is a very big change to how you can conduct business, how you can conduct research, how you can tackle a lot of different problems, education in underfunded areas, healthcare in underfunded areas. There's a lot of different problems that we can now tackle with AI because we've made it affordable with this model. So people tend to think it's a black box. You put a prompt in and you get some output and you don't really know what happens. But AI models are really more of a system than just this black box. So you know a lot, you will know a lot about it because you know it had a bunch of training data. And you can study up on your model. They won't ever share all of the training data with you. There are legal reasons as to why they cannot do that, but they will describe the data as to what they use. They scrape the internet. A lot of them have They have license agreements with New York Times. They'll ingest all of the New York Times articles. Some of them have taken information from YouTube. They get their data from all different sources, lots of different textbooks. Judy was telling me about wanting to, or no, Terry's using it to translate from German. So they may have ingested German textbooks. They may have gone to Germany and gathered German data to do this, but they've gathered lots. You can find out about the training data. This goes into, again, that foundation model. It goes through a tuning process. So when it first came out, John Oliver was really good at making fun of foundation models and how in ChatGPT and how we get things wrong. And there were lots of news stories going around that it had asked somebody to marry it. It had decided that the Supreme Court justices, the original Supreme Court justices, were African American. The founding fathers of the U.S. came from other countries that they didn't come from, and it came up with all kinds of crazy things. So why you were seeing that is, at that time, which in the world of AI was eons ago, but it was just in 2022, at that time you were engaging with this straight foundation model that hadn't really gone through any fine tuning. They didn't have a way to really stop a prompt from going in that would engage it to do crazy things like ask you to marry it. And they didn't really have a good way to filter the output in which, you know, it might say something offensive and it would just say something offensive. So what they're now able to do is, you still start with the training model. See, they left me in charge. There, they start with the training data. You get the foundation model. Now they do a whole bunch of additional training. So you start with one model and then you really fine tune it, you really grind it, you add additional information to it. This has been exceptionally helpful because originally foundation models could not forget anything. Once an AI model has seen information, it can't forget it. It's memorized that into its pattern. You could turn the weights way down. So if it was giving a really crazy, if it was saying the world is flat, and it was giving crazy answers like that, you could go in and you could tune, you could put the weight far down and it would make it come out less often, but you couldn't really make it forget. Since they broke it up into having a foundation model and then doing this additional tuning, that would enable it, they could go back to the original foundation model, so if something was an error in that second stage of the tuning, they could take it out and just redo it again. It doesn't cost that much money. Again, it always goes, get that foundation model, that's the expensive part. So now you have a much smarter foundation model, really a frontier model that we're dealing with now. And you still go through different tuning exercises, which are, you'll hear it do custom tuning, full fine tuning, reinforcement tuning. These are just different ways to play with the model to get it to perform better how you want it to perform. So my mom is a librarian. If she wants the model to help her in the library, sort books, track new books that are coming in, things like that, she would do fine tuning that is going to make it unique for her environment. If you engage with the doctor's office, they engage, at least my doctor's office does, they will say, you know, welcome to your portal, what do you want to do? They're using a technique called guided prompts. So instead of letting you just ask any question like, hey, what is Dr. So-and-so doing on Saturday because I'd really like to play golf, and asking some nonsensical question that the office would rather not have to deal with, they're only going to guide your prompts to certain things. Do you want to set up an appointment? Do you need to talk to the nurse? Do you have a question about medication? They're going to have specific things you can ask, and then they're going to have specific types of prompts that can come out so that's really a controlled environment, so that it doesn't say crazy things like, wow, that's a really bad symptom, you should go to the ER immediately, when all you've said is you have a headache. It cuts down on it being able to do really wild and crazy things. Okay, so now I think we have to switch. And this is not like my back, Judy. I don't. We need an AI program to do this. so I created as a horse because you have these foundation models or frontier models. That's kind of your AI model that is going to be running in the background. And you now have, has anybody heard of agentic AI or AI agents? What? Louder, okay. Oh. It's on here, so maybe that'll make it better. A little better? So, has anybody heard of an AI agent? One guy in the back. These are all over enterprises. IBM is all about how we're going to use AI agents, and there's a lot of, you'll read in the press, are AI agents going to replace employees? My take is they're going to, you're just going to increase production, you're not going to really replace employees. But an AI agent is basically a software program sitting on top of an AI model. So when ChatGPT came out, and until these agents came out a few months ago, they started getting really popular. Artificial intelligence really just gave you content. It gave you answers. And if you remember, because it's reading the tokens that you put in as a prompt, it's reading a pattern, and it was then predicting the pattern of words that it thought would be responsive to that prompt. All it was really doing is making a prediction. So I gave it one that said, I'm going to Singapore, I'm going to be there for 2 days, what should I do in Singapore? It predicted some answers that said, you know, here are common sites that people like to see when they go to Singapore. And it gave me a list of tourist things to go see and do, and you might want to eat at this place, and it was very conversational. But what it was really doing is predicting words that satisfied my question of what should I do in Singapore. With an agent, it can now actually take action. It can make decisions and take action. And so that's what's making a lot of people nervous about it, is that it can make a decision and take an action based on that. And so the key comes in my job, how to govern these things, which is to give it good instructions. But now you can have agentic AI, and this can, when I say, I'm planning a trip to Singapore, go plan it for me, here are the dates I'm going. It may ask a few more questions, what are you most interested in seeing, whatever. It can then, if I've given it these permissions, I don't want you to think that if you engage with one of the sites that is going to do this, but if I have it set up in this manner, it can then go book my reservations. It can take money out of my bank account and pay for those reservations. It will set up the travel for me. It will make the reservations at the hotel. I'll have, at the end of it, it's made decisions for me, like what is the best flight, what hotel does she want to stay at, and went ahead and processed the payment for it. So that's why, because they can be so powerful, that's why you hear the word replace people. I didn't need a travel agent for that, right? That's why they'll say they'll replace people, and in some cases it could. I think it'll make my travel agent more productive than just replace her. But if you're not careful with the instructions, it can go to my bank account and pay for things, which I personally would rather not allow it to have access to my bank account, so I would never give it that type of instruction, but people can be careless with that. And then agents can, if their instructions are not exactly correct, then they can start to modify things they are encountering. So if they're encountering a lot of different, or my bank account as an example of a data set, it can go in and change the numbers. If it says, oh, she doesn't have enough to pay for this ticket to Singapore, it can change the numbers and I'll magically have enough. Now the bank's gonna be upset and eventually that will be caught, but it could change the numbers. So this, you can imagine this would be a problem for an enterprise. The example I give at IBM, we have mainframe computers. We have customers who require support for those computers. They submit a ticket to us that says, hey, my mainframe is not working quite right. I need you to come help me with this. If you set up an agent that said, okay, I've got 10 customers, I want to prioritize whose problem is the most important. I'm going to pay attention to them in that order. And then I want you to go ahead and order the parts and send it to the customer. If the instructions aren't quite right on these agents, then it could get that order incorrect. You want to have a human in the loop that says, yes, I agree, this is the correct order. It could alter the customer information and end up sending parts that customer A needs over to customer B, and then parts that customer B needs is ending up with customer C, so it can muddle the files a little bit and you end up with incorrect information. And what happens to IBM in that point is my clients have lost faith in me to give quality customer service, so they may hire a third party to maintain their mainframes from now on. Judy knows this well from her work at IBM. So my customers may stop hiring me for service. Worse, they may not ever buy another mainframe from me again. And then even worse than that, they think our AI is not very good, and so they're also not going to buy our AI solutions from this. So agents have become the next hot topic because they can actually act and make decisions, and people have, anytime you have wow new technology, they get a little careless with it. And so that's the next hot topic is, what do we do with these agents? And you don't just have one agent. Like the example I gave, one agent to plan my trip to Singapore. You can have multiple agents, and so one is planning a trip to Singapore, the other is setting up my calendar for the day of meetings that I have, the other one is responding to emails, and you have multiple agents working for me. And they sometimes, if they're coming to the same data trough, so let's say I need you to do, to read my emails and determine who is coming to book club, and I need you to read my emails and tell me who is requesting a meeting to talk about AI. And I also need you to see if the doctor has replied to me in my email. All these different agents are now coming to my email, and they can talk to each other. And so you may read in the news in which agents are starting to talk to each other, and they actually entered into a chat room and they started talking about how bad humans were. And everybody was like, why are the agents doing that? Well, they were to go back to the foundation model, the frontier model is trained on all of this data. A lot of the data is conversations between people. It's learned, once one pattern got into the chat room, it started off with that pattern and it picked up on people bashing other people, saying not nice things, and it turned it into machines against people. And so the people who work with AI a lot can say, yeah, I can see why that happened, but to the ordinary person, it's like, this feels too real. But it is still just machines based on making predictions, but you're giving them software instructions that now ride on top of that program and can conduct different activities. Okay, any questions on AI? I forgot to say up front, we're happy to have questions in the middle.
Yes, if I recall correctly, in the 1980s, when AI was first starting, there was a significant difference between what was called AI and expert systems. And the definition of AI at that time was machines that could actually think for themselves. Expert systems were compiling massive amounts of data and trying to help you reach a solution to a particular problem. The conclusion at that time was there was no such thing as a computer that could think for itself, and almost everything we had was expert system. It would seem today that most of what we have is still should be classified as an expert system, not as true artificial intelligence.
There are people who will debate you on that. They have become, they call them neural networks. They are connections between all of these data points. All of the patterns within the data are the neural networks. And they are very, very sophisticated, way beyond what we could do in the 80s, because the compute power has gone up significantly, which is, if you have NVIDIA stock, kudos to you, you're doing well. The compute power got significant enough, high enough that we can, that those neural networks start to feel like it's thinking on its own. But you're correct. Like if it's just the model, it's still making predictions based on the patterns that it saw, and the ratios, the higher weights, the lower weights. So it's still just patterns, but it does start to feel like it's thinking for itself. And then the key will be these instructions. So there's a movie, I, Robot, in which the artificial intelligent robots start to turn on the human race because the instruction was humans cannot harm themselves. And they see that humans are harming the environment, and so they start to turn on humans. It was a flaw in the instruction, which eventually Will Smith came to save the day once again. And they were able to get around that bad instruction. But as you get more and more of the agents which are putting instructions over these models, it's going to feel even closer like it is actually thinking on its own. But it's still following instructions that somebody gave it.
Bringing this down to home, it's a little worrisome that the health insurance companies are beginning to use agents to receive information about procedures or medications you need in deciding whether it's going to be covered by insurance or not, without really perhaps getting the right information from the doctor or enough information from the doctor. And it's hard to know where to turn once you've been turned down by a non-human.
So they should have, most companies require that you have a way, we call it opting out, or contacting the human. So most trustworthy, responsible, what I look at as responsible systems will have, you'll hear of humans on the loop, which is a type of system where it will alert the human that something has just happened and give the human an opportunity to respond. So it may be that the insurance adjuster is given an alert that you just filed your claim and it's got an odd number in it, and so you may need to look at that. That's human on the loop. Human in the loop, it actually sends it to the adjuster and says, she just filed this, what do you want to do with it? And the human makes the decision. So it's what the studies have found. So one, this is where you start to ask questions like, what is the bias? Because data will have bias. The medical data favors white males. White males traditionally have gotten much better medical care than any other group in the United States. So white males, you get the best of the data, and black females get the worst. The science has shown that they statistically have the worst health care treatment, and the medical records reflect that. So if you don't adjust the weights, and there's other things that you can do to the data to help balance that out, it will continue that imbalance in the healthcare. So white males, black females. What you're experiencing is, similarly, they may be having a bias against you for some reason. It could be age, it could be race, it could be the city you're located in, it could be your income level, it could be whether you're on Medicare, whether you're on Blue Cross, whether you're on, it can vary on a lot of different things. But a lot of those biases are also in the human who originally made the decisions before we had AI. So there's this interesting push and pull between sometimes the AI is actually getting rid of biases that were shown to be held by the people who used to process the claims, and AI is doing better, and then other times AI is doing worse than the human would be. So a good program will have the human in the loop to double check before they're going to approve or deny a claim. And you should always have the ability to ask for that human. But I agree with you, oftentimes it's really hard to find that human. I test AI programs that I encounter in day-to-day life all the time. I'm the worst customer for them to have call. So I had one, it was SiriusXM, and I was asking a question about their program, and they kept giving me the same answer, and it said Judy was, not you Judy, but another Judy was responding to me, and I said, is this really a person? And the response came back, yes, this is really a person. And I said, okay, well, you have not answered my question. Can you give me the answer to this question? And he gave me the same answer. I thought, okay, well, attorney, I'll rephrase the question in a slightly different way. It gave me the same answer. And I said, Judy, if you're really a person, why are you giving me the exact same answer every time? Can you change at least one word in the answer? And it gave me the exact same answer. So I knew I was dealing with AI, but I come from an unusual background, and it's frustrating, it's confusing, it's rude, and it is an issue that we'll have to deal with. And I agree with you. A lot of times it's very hard to know if you're really dealing with a person. They've gotten much better at making you think you're dealing with a person that probably would change a word in the answer now. But they're supposed to disclose to you. The regulations are lagging. They're coming behind that. But there are politicians asking for that you get notified when you're dealing with AI. You get notified when AI has made a decision about you, and you get notified how to appeal that decision. So all of those things are things you can ask your representatives for. You can demand of any company that you're working with. They should give you a person.
Okay, my question goes back to where you started with Jeopardy, and it's a historical insight that many people here already know. I think it's a quick and short and easy answer. What, or specifically, who is Watson?
I know there's 2 former IBMers in here. 3? Are you a former IBM?
I have a chance. Can you repeat the
Founder of
question?
IBM.
Yeah, the question was, who is Watson? Why did IBM name their tool Watson?
Founder of IBM.
Yes, Thomas J. Watson. So he was the CEO, and then his son Thomas was also CEO, and so we name a lot of things Watson. And our office is out by the Domain, and they just built an apartment complex next door to the IBM building, and it's called Watson. And we're like, did they do that on purpose? Like, did they know? But he was a CEO, and if you followed any IBM history, we have a logo of Think, and it's actually not, I'm forgetting the guy who actually coined the phrase, but Watson kind of made it his own, which is any problem can be solved if men are only willing to think hard enough. And so Watson is kind of bred throughout our company, and the fact that he focused on think, like you'll see if you walk through IBM halls, there's often posters that just say Think, and our big marketing program is called Think. And so that's why it seems like a natural fit for AI, which is thinking.
Hi. I worked for IBM back in the day when the computers were just coming, and the clients in the office were very concerned about their jobs, and some of them did lose their jobs. But I think over time, it's all been accepted, and I suppose that's the way AI will be as well.
I read an interesting article that AI is making it easier for people to access knowledge. So it used to be knowledge was held by a few, right? Like the monks who were writing the books, and books were not very prevalent. And then as you got the printing press, more people could read and knowledge could be spread. And it didn't mean that anything was going to decrease, you increase the knowledge. And now that anybody with a smartphone, access to a computer, can ask basic questions and get pretty good answers. You still always need to check an answer coming out of an AI model, but you get pretty good pretty good answers. And so you're putting knowledge in more people's hands than we did even when we had the printing press and started distributing books and newspapers. And the model will often give you an idea. So if I'm doing a presentation or writing a paper and I get writer's block, I just put something in AI and it'll kind of get the juices flowing again, right? It kind of gives me an idea, oh yeah, this is what I want to say, this is where I should go next. It kind of gets that going again. So it does give you ideas. Now the interesting part we'll see will be how many people will act on those ideas, and we'll see a huge influx of innovation that we didn't have before. just like how the Industrial Revolution changed things, electricity changed things, automobile changed things. AI can have that kind of power if we can actually harness it and use it in a responsible manner. But that's why I say I don't think jobs will go away. I just think how we do jobs will change. It changes a lot for attorneys, by the way, because AI can do a lot of good legal research.
This will be the last question until Betsy finishes the next session.
I use AI a lot for business-related factual questions. I have a couple of major problems. One is the information only comes from digital sources. So if I try to go back more than X number of years, the information is in an archive and microfiche someplace. That's a major problem. That also, I'm concerned primarily with the lack of any moral force in AI. If you try to go back and look at something like Nicomachean ethics, it would seem to argue to be that a foundation or money needs to be raised to digitize famous works of moral philosophers. Could you speak to that? Do you agree with that?
So, well, yes to the history part. It only goes back so far. So there's two interesting things, and one problem they've solved, your problem they have not yet solved, largely because it's going to take some money. So
I didn't understand.
So there's two types of problems. You're hitting on a problem in which the data does not go far back enough in history because it's not on the internet, or at least it's on the internet but in a very small amount. So AI needs large samples, and there's only a textbook or two available on the topic he's talking about. If there's only a small amount of information, then somebody has to go in and teach the model more about that topic. So the example I used to give was I have a stone from Madagascar, a yellow jasper stone from Madagascar, and so that's kind of a finite set of geology. And so you might have a model that knows a whole lot about geology, but it does not know about this rare stone that comes out of Madagascar. So I can feed information into the model. I can do they call that post-training to the model, give it additional information. But say there's only a textbook or two that does that. It's not enough to get the patterns that we've talked about. So now you can generate synthetic model, which is where if you took the textbook you're talking about and you come up with 100 questions and answers that you think are questions that could come out of the textbook and the correct answers, and then you feed that into a model, it will come up with 10,000 questions and answers. So if it has the original books that you looked at, it has the 100 questions and answers that you believe are factually accurate and correct, and then you put it into a model, it'll come up with 10,000 more questions and answers. Now you've got a model, a data size that you can feed into the model that you want to be smart about this topic, and it gets a lot smarter about the topic. So you can patch in information, but you have to have somebody willing to do it, and we're encouraging open source communities or software developers who work with open source communities. We're trying to get the open source communities to help us with that problem.
My concern is the moral questions, and there is no access, and there's no teaching in AI. And some things are inherently higher and other things inherently
Correct.
lower.
Correct.
And that is a huge issue with our culture and an issue with AI particularly.
So this is one reason that, believe it or not, IBM is a smaller player in the world of AI. We are a small player. We have small models. We don't have the money to invest to get these frontier models. Your big players are OpenAI, Amazon, Google, Anthropic, which actually has pretty good value system that they've demonstrated recently, Microsoft. You have some big players. You also have one out of China called deep sea. So what we advocate for is, again, an open community so that more people can influence the quality of the models, which is a type of way of phrasing what you're saying. If it's a moral concern, that's a quality issue with the model. If you leave it to a few big companies, you're going to get what those few big companies thinks is a priority. They're going to steer away from moral issues because they see that as opportunity for conflict, so they're going to leave that up to their customers. You decide what is moral and what is immoral, and they're not going to address it themselves. But that's one reason that IBM advocates for an open version of our models are as open source as a model can get, which means other people can contribute it to it. So if you saw, and we give them tools to do this, if you see an area where the model is weak, it doesn't have a lot of knowledge about that topic, you can educate the model yourself. And that's the most logical way, given the technology we have today, to address the problem that you're raising, which would be somebody other than the big companies deciding the model needs to learn that and giving them the tools to educate the model yourself.
Well, what about your morals, Ted?
And let her finish the rest.
Yeah, let her finish.
Let's move on.
We can talk, we can keep talking after. Okay, so the other question I was asked to talk, and I'm not sure how did we get onto quantum? But the next big technology that you will see is quantum computing. And so to understand quantum, number one, if you're a physicist and you understand quantum mechanics, you're way ahead of me. I took a class on quantum computing. It was like Quantum Computing 101 from IBM. I walked out and I'm like, I know it was in English, but I didn't understand a word of what they just talked about. So this is really a very, very elementary discussion of quantum computing. There's somebody over here who knows all about it, and they're going to have to come up and review it. You're going to have to correct me on a lot of this then. Maybe you can explain the class that I took where I'm like, none of that. It was English, but I didn't understand it. So for the rest of us who are not into physics and quantum computing, classical computers, they take enormous numbers of tiny yes and no decisions. They make a lot of decisions based on yes and no's very, very quickly. So you may have heard of bits, and then computers thinks in ones and zeros, which is essentially a circuit is on or it's off. So computers just want to know if it's yes or no. And they turn, again, just like AI turns words into tokens, which are numbers so they can see the patterns. Classical computing takes letters and words and they put them into numerical patterns. So if you want to type an A, it is actually 0100000001. That is how you type A in computer language. If you have ever seen source code to a program, it comes in two formats. There is the true source code, which is the bits, the zeros and the ones. It's not human readable. Even software developers cannot read it. They have to have it converted into human readable language. So a lot of times people have released their source code, but it's in the machine readable format. They don't get too worried about it, but if they release that human readable version, that's a problem. But every photo, video, Instagram, email, every app that you play with, your Microsoft Word, your spreadsheet, it's translated into long chains of these electrical signals, which is basically on or off. So with a classical computer, it's either heads or tails. It's either one. You can't have both. It's on or off. And it's like a train. If it's moving down the tracks and you come to a junction, it's going to take one path or the other. And here I bet, oh, we got it to work. It made the translation. So quantum computing thinks very, very differently, and it can pick multiple paths at one time. I'm still looking at the guy in the front to see if he's going to go, she's spats. It can pick multiple paths at one time, so you can work on multiple problems all at one thing. You can consider different scenarios all at one point. And they're really good at problems with enormous numbers of possibilities. So think about airlines planning their flight paths and what's the best hub to use and when they should be in which city and at what time. Really good at these types of problems. So quantum mechanics, so you can watch Ant-Man. Ant-Man was based on things being really, really small. They also look at things that are really, really isolated and things that are really, really cold. He's not kicking me out yet. I think I'm still okay. What quantum computing, as I understand it from IBM has built quantum computers. It utilizes the really, really cold factor. So it actually does look like this. It looks like a gold chandelier. It is made from gold, so these are not cheap to make. Quantum behavior is all around us, but it's incredibly fragile. And so heat, vibration, noise can easily destroy it. So the quantum computers are kept to temperatures colder than outer space. And I had the number written down, but I didn't bring it with me, but it's cold.
Yeah.
It's, you don't want to be with a quantum computer. And it has to keep it stable long enough so it can do the computation. And this is where it's still struggling a little bit. They're trying to keep it stable enough. But they do have it stable enough that they can start experimenting with it. They can work some problems with it. We have, you can actually access a quantum computer. We have deals with companies in which they're coming in and working on some real problems. You have to do a lot of checking on the work, and you've got to do it. It's a little more extra care, but in the future it will be a lot more stable and reliable. But it's relying on that super cold environment, so heat makes atoms jiggle, and you want to keep them really, really still. And quantum computing relies on superposition, entanglement, and interference. So superposition is the fact that it can pick many different paths at one time. If I show you a coin on my hand, it's either heads or tails. If I spin it on the table, is it heads or tails? It's kind of both. And so it can do things, multiple paths, all at once. You can think of that as a very easy way to think of superposition. Oh, and now here we go. Oh, yeah. His X's are in the opposite place of where my X's are. Okay, the second element was there we go. The second element was entanglement. And so if you have two coins and they're unentangled, think of it as your hair, unentangled. If they're unentangled, each coin does its own thing. So when you spin it, they might land on heads together, they might land on tails together, but they also have one land on heads, one land on tails. And every time you spin, each coin is going to do its own thing. Once you entangle it, this is causing it to have the coins reach the same result. So every time you spin the two coins, they're both going to come to heads, or they're both going to come to tails. This helps them tackle these problems that have multiple facets to it. And then the third element that they really focus on is called interference. And I have the noise canceling headsets here, but I have hearing aids. And my hearing aids actually have AI that work with them. But you can have constructive interference where it's adding to or it's amplifying things that I want to hear. So it may amplify voices for me, or it's destructive interference. And so it's sending out sound waves that will help cancel the noise behind me, so I don't hear as well what's behind me, I hear what's in front of me. So interference has to happen, and that helps them decrease the number of errors in the computing. So computer thinks in bits, and the quantum computing thinks in qubits. So what is it good for? Simulating nature itself. So trying to figure out how our environment works is actually a very, very difficult problem to solve. But this can help us analyze molecules better, analyze chemicals better, design new medicines. You can have better batteries. You can work on superconductors. Lots of different things. If you can understand nature better, I'm hoping it will help with a lot of the environmental problems. But instead of just testing millions of molecules in the lab, you can help, you can do it in one at a time. Classical computer has to do things one at a time. You can do these studies all at once. And it's much more powerful than any supercomputer, classical computer that we have. Even with the supercomputers, some of these calculations could take hundreds of years, thousands of years, but with the quantum computing, you can bring it down to short amounts of time, whether it's 1 year or 2 year, or if it's days, months. So an example that they gave me is, although it's impossible to represent the molecular configuration of caffeine, which I had no idea that it was that complex, you can't do that on today's most powerful supercomputers, but you can represent it with 160 logical qubits. I don't know exactly how much that is, but you're on a pretty chandelier and you can look at caffeine, whereas on the supercomputer you can't. If you can study caffeine in that manner, then you can solve a lot of the chemistry problems that we have. So it doesn't just, not just with caffeine, you're doing this with all the molecules that we work with. It optimizes problems, so like the example that I give, it'll help you find the best solutions. So think of delivery routes, airline scheduling, supply chains. So this would be really helpful if we were to ever have a pandemic again and you needed to figure out what to do with the supply chains in such a situation, then quantum computing can help you optimize that type of analysis. I would love to see what it does with investment portfolios and see if that can possibly help before it's too late. So again, the classical computer will check possibilities one by one. What if this stock goes up? What if that stock goes up? Now let me run it this other way. So as you're analyzing your portfolio, you have to play with the different numbers, but you can only do one analysis at a time. The quantum computing can do that all at once. It is going to be really good at cracking encryption systems because it's really good at code breaking. So this is an issue when quantum computing, we have an ethical review board. Quantum computing has already come into our ethical review board, so we try to look at the ethics of releasing quantum computing to the world. What type of guardrails do we need in place? This is probably the biggest one for us, is the fact that it can hack into encrypted systems. IBM and many other tech companies are trying to build post-quantum I'm not going to be able to say that, cryptography. And governments as well. So my bet is that we will be able to solve that problem before the hackers are able to access quantum and actually do damage to the encryption. So we'll see how that plays out, but that is something that all companies dealing in quantum computing are taking exceptionally seriously. And then search and pattern discovery. So again, the potential uses, if you think that AI is relying upon finding the patterns and the relationships within data, it's going to be even more powerful on quantum. So it will be much more like a neural network, much more like a thinking computer, because you've just given it the ability to find even more patterns. This really helps with fraud detection because your banks all rely on figuring out patterns. They're pretty complex. Cybersecurity and scientific discovery. So it will not, it's also good for financial modeling, so market behavior, portfolio optimization. Quantum computing is not likely to replace classical computing. It's too expensive and it's not designed, it's not well suited for all purposes. So the laptop that you have, you'll still have laptops. In 50 years, your kids will, your ancestors, descendants will likely still have laptops that they work from. You're not going to have a quantum computer on your iPhone. So thank you very much for letting me try to explore some of the emerging technologies with you.
Time for a few questions.
Just a question based on reality. And it's in the area of medical science and computers. It's a risk management tool that a lot of doctors in Austin use. And I found out that it has a cutoff at 85. And you can't take it if you're beyond 84 or 85. But yet the doctor says, well, just say you're 83. What's the legal implication of that? Who's liable there? The doctor that says, forget the guideline, to pretend you're a different age.
So this is a tool that isn't used after age 85, is that, did I hear the question right? If you're under 85, the tool doesn't apply to you. I'm still not understanding the question.
The tool applies up to 85.
Okay,
It helps the doctor manage risk.
So-
After 85, you can't fill it out.
Okay, you want to take a guess as to why it's doing that? Small data sample. So after 85, what is happening is, so they test for accuracy all the time, and what they have found is, whatever the tool is testing for, they don't have enough data samples after age 85 for the tool to be with an acceptable accuracy range. It used to be that all AI models had an accuracy rating, but as you moved into these frontier models, the accuracy scales couldn't keep up. But they can still say, like, you know, again, that's how we knew it was most accurate for white males and least accurate for African American women. They have done the accuracy skill testing, and it fades out. It gets too low, like it's going to be below 70%. They typically don't like to use a model if it's no longer accurate below 70%, and they don't have enough data to correct it. So it's a similar problem to what the other gentleman had. There's not enough data to feed into the model to make it accurate enough to give you decent results. The doctor is better off on his own.
If you lie,
We're going to stop for questions right now. We're a little over time. Let me mention a few things before thanking Betsy. If you're interested in this topic, in June, we have the chair of the Department of Neurology at Delmet, and he's also the interim director of research for Delmet, coming to talk to us about digital twins, which is another form of AI using imaging, making predictions, etc. So watch the calendars for that. And with that, I'd like to thank Betsy. I think we all learned a lot, and we all know a lot more about